Okay, so here, I'll say that part again. So, depends what I said.
I don't remember.
The second they put a semicolon as their statement delimiter, they've basically said nobody is allowed to use this symbol as part of their program from this point forward, except to delimit statements. Okay, so I'm not sure that's an advantage. You said the advantage is that it would be rare. You missed a quiz, Baker.
Took a test.
Did you pass?
Yep. Baker.
Okay, so you said that the so you're saying one advantage would be that the compiler itself would rarely run into semicolons.
Well, no. Like, run into a situation that, like, you can say, like, set up that print line as a semicolon.
I've never seen this.
Okay.
But it won't usually encounter that, because you don't really use semicolons very often to name anything that you would use in a program.
Okay, so if I'm twisting your meaning a little bit here, you're saying that an advantage of using something like a semicolon is, since it's not often used anyways, it's a good choice for a statement delimiter as opposed to something like A, which would be used often in other things that are not statement delimiters.
And also, you can still use the whole alphabet if you have. Because, like, if A was your delimiter, then you'd have to name all your things without A's in them.
Sure. Okay. Okay, so the angle you were going for is that if we're going to use a delimiter, let's at least use one that is likely to be used a minimal amount of time. Okay, fair enough. What else? Is that it?
That's it.
Go ahead.
I just said it was like easier to read. I was thinking just because if you have to have something at the end of a statement, you can tell like, oh, that's the end of a statement. But I mean, maybe that's wrong because you'd be like breaking new lines anyway. But I don't know. That's just what I thought.
Okay, so a possible advantage is that it's easier for a human being to read the code.
Yeah.
By using some sort of easily detectable symbol to delimit statements, as opposed to not having a delimiter, where your code could all run together, or it's very much like reading a book. So if you think about reading a book, and you know at the end of a sentence, you're at the end of the sentence because of the period, right? Okay, so if you're missing ends of things in a language, then somebody who's reading your code might feel like a run-on thing, and it might be difficult for them to really read it. So I think that's reasonable. Go ahead.
Did somebody say, like you can break up statements across multiple lines if you're not using line break as your delimiter? Like I've seen some people like call functions that have like a lot of different arguments, and they'll break up the arguments on each line.
Oh, that's a really good one. Yeah, that's maybe the best advantage so far. I hadn't even considered that. So what he's saying, if you've ever run into this, like in a language like Java, let's say you have a method that takes, I'm just going to be obscene here and just say, let's say we have a method that takes 30 inputs, 30 parameters, okay? Rather than having on one giant line where you're passing in parameter 1, parameter 2, parameter 3, a lot of people keep pressing return and enter it so that your method call ends up being, let's just say, 30 lines long, where each parameter is right on top of each other with the semicolon at the end. So in a language that has a delimiter like a semicolon, you can legally do that. You can break things up across lines because white space is ignored, and have something like that be palatable, as opposed to if you were dealing with a language that he said uses the end of line character as the end of your statement. Well, then you're going to have to fit all those parameters on one line, and you'd have to scroll a whole bunch to get over to that side of your program. So that's a good one. Star for the day for Matt. Anybody have anything that beats that? I think that's a pretty good and relatively rare. Oh, did everybody hear that Simon won a moped?
All but a shoe-in.
All but a shoe.
Formality.
All right, somebody want to get the front lights, please? I'm all but a shoe-in. Like, what are you talking about? I pulled 2 legendaries out of a pack of 5.
You know someone else from there, and someone like they caught him, gonna walk up. No.
Mine!
Way before.
Yeah, let me just like sit on the moped and be like, yeah. Start walking towards it.
Yeah,
And the winner is what
All right. So, if I remember correctly, last time we left off, we have our parser working correctly now, correct? So it's splitting everything into tokens where we have one token. We're ignoring spaces. We are capturing all the semicolons. We are correctly capturing things like less than or equal to. We have the Dane run of parentheses here, correctly being captured. We have a less than or equal to somewhere in here. Here we go. So it appears like we are capturing all the tokens correctly. Okay. After we read in tokens, what do we do next? Now we're almost repeating ourselves, but we're dealing with a more complex language now. After we read in tokens, what comes next? Lexical Analyzer, right? What does it mean to lexically analyze our code? If I run this again, what would it mean to lexically analyze this?
Figure out what all the tokens mean.
Or this? Well, remember back to lexical analysis. You're wrapping it in kind of almost like a structure. Let me give us our example here. So we had identifier, we have literals, and we had an operator. Okay, so anything that's an identifier, we need to put up in some lookup table. I'm just getting us our example of how that lexical analysis looked. Okay, something like this. So whenever we ran into an identifier, we'd add it to our lookup table. We'd wrap it inside of a generic. This is an identifier. This is a the code to look it up in our symbol. Here's an operator. Here's another identifier. Here's an operator. Another identifier. Here's an operator, and here's a literal. Now our language is more robust at this point. Do we still have identifiers? Sure. What's an identifier in our current language? Things that are not what?
literal.
Okay, things that are not literals. That's a true statement. So then we could say, what's a literal? Things that are not.
You're not wrong.
Reserve symbol.
Okay, reserve symbol. So is that a identifier or a literal?
It's a reserve symbol.
Reserve symbol. What about this? What's this guy?
It's a reserve word, I guess.
Okay, why? What is int in Java? The type. So this is a type expression, correct?
I don't know what to do with it.
Go ahead.
There's a C450 reading that mentioned this as like words, keywords like and cannot be used, cannot be usurped for other purposes in the language. This does not apply outside the language. You may be able to name your favorite child or pet, and local customs may vary.
That would actually be really funny. If you named your kid like, like first name, middle name, like some expression. Yeah. This is I++ Lippman.
Plus semicolon.
This is S dot length.
Probably not the.
Parse it.
No.
Parse it.
Integer dots parse int. Okay, so this would be a type, correct? So we're going to probably want to wrap this guy as a type. So we just added a whole new element to our language, this concept of types. So let's get back into our code over here. So I'm going to go back into our language reference. And we're going to right now we have this string here called special characters inside of our source reader's tokenized string. We're going to want to bring this guy into our language ref. So now we have this thing called get special characters. So we already have something called get ops that returns a string array of ops. Now we have something called, and these are actually ops as they've already wrapped them. Now we have get special characters, so this will return that array of special characters. Why do they have it return an array? Because that's what we need over here. So this guy is going to bring in language reference dot get special characters. So there's our array. Okay, so rather than having it localized inside of source reader, I went ahead and I just brought that into our language reference class so we can keep track. If we're going to add anything here, we add it to this place, and any place that references our language, we'll grab it from here. Okay, but now we also need to have types. Okay, let's go back to this guy. So we'll say static string array get types. So types are going to be int. Should we just do all of the primitive types? Sure. Sure's. Okay, what are all the primitive types here, Skippy? Int, that's one of them.
Shorts.
Okay.
Doubles. Floats. Boolean. Oh, I said float there, buddy.
It's like a small rope.
Oh, it's and short and long. So long. I forgot one. Okay. Chars. Oh.
Chars, okay. What else? Byte.
Byte.
Byte, short, int, long, char, float, double, boolean. Those are our types. So for right now, our language is going to support only primitive types, right? Once we start thinking about object types, we're going to have to expand on this potentially. So this guy will return types dot split on space. Make sense? And actually, just for consistency here, I'm going to change our string ops here and say this guy is an equal sign, a plus sign, a minus sign, a multiplication sign, a division sign, and we're going to have modulus in there too. Okay, so those are my operators. Okay. this point, they're just mathematical operators because we haven't done anything with Boolean expressions yet. Okay, let's get back to our program. Make sure this guy still runs. Okay, so this is a type. What's I? I is not a type, not a reserved word, so it's an identifier. Semicolon, type, identifier, delimiter, type, square brackets, a special character. What's 100? It's a number. How do we tell numbers apart from, it's a literal. How do we tell literals apart from identifiers?
They can't start with, well, identifiers can't start with digits.
Okay, identifier can't start with a digit, can't start with a number. Is the only kind of literal we can have a number?
No, you can have string literals.
String literals? What would a string literal look like?
Starts with double quote.
Starts with a double quote. What would a char literal look like?
Starts with a single.
Okay. So, are all those literals? Okay. So let's go back to our language reference. Can language reference determine whether or not something is a literal?
No.
Like, could we write a method in here? Static Boolean is literal. And have this guy take in a char as a parameter. Could we return whether or not this is a literal?
No.
Why would we not want to take in a char? Actually, let me ask you this for starters. Would our tokenizer right now, would it take single quote, a single quote, and would it get that as one token, or would it get that as multiple tokens? Well, is single quote anywhere in here? So it'll get it as one token, won't it? Do we want it as one token?
I know we have none with literals as well.
So it's a language decision. So you want to get all literals as a single token? So right now, will we get string literals as one token? We get char literals as one token, and we get number literals as one token. So this guy is going to take in a string token, and we're going to return true if that token is a literal and false otherwise. Correct? Now we know for a fact that tokens will never have a length of 0. We wrote our tokenizer specifically to make sure we ignore tokens that are based on white space. All right, so I can always look at character 0. Well, for starters, string literal starters is going to be equal to a single quote, a double quote, and what else? A 0, a 1, a 2, a 3, a 4, a 5, a 6, 7, 8, 9. Anything else? Literal starters?
Like Boolean.
Will we look at? I think we have to treat Booleans as special cases. Because for all these, we're looking at just the first character. The first character of any of these So here I'm going to actually make this a string array called literal starters, and we'll just do dot split on a space. I want to do something here real quick. For string s in literal starters, and then for right now, I'll just return true from this. I just want to test this thing real quick. I'm interested in making sure that when it splits on a single quote, that it correctly splits that into a string that contains one character, not a string that contains two. I think this should work correctly. Let's go out to driver real quick. I'm not going to process our statement. Instead, I'm going to call language reference dot is literal, pass it basically nothing. We should get a whole bunch of linked ones. Yep, okay, we're good. Okay, so each time through here, we're going to ask the question. We're going to say if token dot char at 0 is equivalent to s dot char at 0. If that's a true statement, that means that the token you passed in matches, its first character matches one of our literal starters, so we will return true. Correct? Definitely a literal. But before we just return false, we're going to say if token dot equals true or token dot equals false, actually we don't even need the if, we'll just return was return that whole thing. So if it's either a true or a false, this whole thing will be true, but we'll return it. If it's neither a true or a false, it will return false. So I think this code should properly detect whether something is a literal. Make sense? All right. Now, back to our source reader. Now we're calling process statement. We no longer need this reserved word thing, do we? That's part of our language now. Okay. Still need a symbol table. Still need our token stream. We will have a syntax tree. We don't need this is reserved word thing. We don't need this is literal thing. Lexically analyze, huh?
Everything's getting destroyed.
So here's this thing called process statement we wrote, right? What does process statement do? It reads in our string, our file, one line at a time, and calls tokenized string on each one of those. Here's tokenized string. Tokenized string what does he call? So he doesn't call anything else? So what's all this crap for up here? What's this add subtokens? Didn't we use that?
No. Started making that fast before.
Never used that? So, somebody uses it.
Somebody's angry. He's angry.
No, we used it. Did we do find matching delimiter? Yep, use that in there. Do we use match delimiter? Oh, let's go ahead and gut our lexical analyzer. We don't need that, right? Well, in syntax analyzer, it doesn't even make sense anymore. A whole new kind of language at this point. Okay, well, now that we've cleaned house,
Write it again.
let's get back to our lexical analyzer. What's this guy supposed to do? Reads through our linked list of tokens. And wraps each one with the appropriate lexical container. So that is identifier, comma, colon, index for identifiers. What about for operators? Or what about literals? Go ahead.
Just in the able brackets.
Okay, but that was when our language was simpler. That's how it did do it. You're right. But now our language is a little bit more complex. Would it maybe be of interest to us for future reference to mark operators as operators, to mark so why don't we say op colon operator for operators. why don't we say lit colon literal for literals. What else do we have besides identifiers, operators, and literals? Reserved words. So how about reserved colon R word? Let's spell it out. Reserved underscore word for reserved words. Anything else we need to support? Huh?
Types.
Oh, types. Thank you. Type. Now, remember, as of right now, our operators are only these guys. Math operators. As opposed to some of these guys fall into the category of Boolean operators. Do they not? Well, what if we have a get math ops and a get. You leaving, Joey? Oh, okay, because I'm about to give homework assignment.
I'll be back real soon.
Get Boolean ops. My Boolean operators are what? Less than or equal to, greater than or equal to, equal to, not equal to, and, or. Good enough for now? We can do the XOR thing too, but let's all right, so these are our Boolean ops. So now we've gone back to source reader. I'm sorry, yeah. So now we have a math op, a mop for math operators, and we have a bop for Boolean operators. That make sense? So, for your homework, write Lexical Analyzer in terms of our current program. I will give you the source code as a starting point. I'll zip up the folder and give you the source code as a starting point. Questions, and this is due on Wednesday. Questions, comments, concerns, bribes. I have some major concerns. Friday, I'll have a whole nother assignment for you to do Wednesday for Friday. It's probably going to be syntax analyzer. Just think, in 1 week you'll write both a lexical analyzer and a syntax analyzer, and you'll be so proud of yourself. All right, I'll see everybody on Wednesday. I'll get this put up on Angel now.